Welcome to 21 Days of Code. Today we will be solving problem 141, linked list cycle. Given a linked list, determine if it has a cycle in it. This here is just the description of the input, that is pos. If it is equal to -1, then there is no cycle, and if it is equal to any other number, then it is the index of the node to which the last node is pointing. So first of all, you should know what a linked list is, and if you don't have any idea, make sure to check out the link in description. For a basic understanding of linked list, a linked list is a data structure which has nodes and connected through pointers. For example, this here is a node of a linked list, and it has a val int which will store an integer value, and this next pointer which will store the address of the next node in the linked list. So it is connected through pointers. For example, this here is a classroom and it has a teacher and 3 students, 1, 2 and 3. The teacher knows the roll number of only student 1, student 1 only knows student 2, and student 2 only knows student 3, and 3 knows no one. So teacher will be the head pointer, and this will be pointing to 1, this here will be pointing to 2, and this here will be pointing to 3. So this list will become a linked list. So as you now have a basic understanding of linked list, let's now proceed with the question. This here is a linked list with a loop where if we go from 3 to 2 to 0 to -4, we again end up at 2. So if we traverse this linked list, we will end up in an infinite loop. But if this connection was not here and the last node would be pointing to null, then the linked list would end here and there would be no loop. But here we have a loop. So how to detect this loop? First, we can either store the addresses of these nodes in a hash map or an array. If you have done the previous questions, you must be familiar with hash maps. And if you are not, make sure to check out the link. So here we can store the addresses of these nodes in hash maps and check if we have already iterated through these. For example, we check if 3 is in the hash map. If it is not there, then we store 3 and move to the next element. We check 2 is in a hash map, it's not there, we store 2 and then move on to the next. Store in the hash map, move on to the next. Store in the hash map and then move on to the next, and we check if 2 is already present in the hash map. Then yes, 2 is present. So we have detected that there is a cycle. So this is one of the primitive ways, and you can try this approach on your own. What we are going to see here is the 2-pointer approach. So how to implement it? First, we will have 2 pointers. One, the slow pointer, and one, the fast pointer. The slow pointer will move 1 step at a time, whereas the fast pointer will move 2 steps at a time. So if the slow pointer is here, the fast pointer will be at 2. So this is the location of the current. So we will check if slow pointer is equal to fast pointer. That is, both the pointers are on the same address. If they are on the same address, that means loop is present. If fast pointer reaches the end of the linked list, then there was no loop. So we can check this. Slow pointer is here, fast pointer is here. So they are not the same. So we move the pointers as here slow pointer and here fast pointer. So again they are not same. So we will move the pointers again. Here slow pointer, and now fast pointer, as it moves 2 steps at a time, -4 to 2 and 2 to 0. Then fast pointer will also be here. So slow pointer and fast pointer are at a common location. So that means there is a loop. If you want to check this here, slow pointer is here and fast pointer is here. Not equal, we move ahead. So slow pointer is here and fast pointer was here. So it moved from 2 to 1 and then 1 to 2 because of 2 steps at a time. And fast pointer is also here. So as the pointers are on the same node, that means loop is present. Here also, slow pointer here, fast pointer here. So not equal, we move it. Slow pointer here, fast pointer here. Not equal, we again move it. slow pointer here, and fast pointer from 5, and then it will go on to 2. Fast pointer here, not equal, we move one more time, slow pointer here, and fast pointer we move from 2 to 3 to 4. That is 2 steps, it will come to 4. These are equal, we got our loop. This approach is better in time complexity and much better in space complexity than our previous approach. So let's code it. First, we will check if head is equal to null. If head is null, there is no chance there is going to be a loop. Then we define 2 pointers, first pointer and slow pointer. The slow pointer will move one step at a time, so we initialize it with head, that is the first node. The fast pointer is going to move 2 steps at a time, so we initialize with head.next, that is the second node. Then we define a while loop. The condition in the while loop checks if there is an end to a linked list or not. That is, if fast pointer is null or the next pointer to the fast pointer. That is, the pointer connected to the fast pointer is equal to null. If they are null, then the while loop will break and we will return false. So here we will be checking if the linked list is containing an end or not. If it contains an end, then the last node will be pointing to null and our loop will break. So inside the while loop, we check if fast pointer is equal to slow pointer. Now what are we exactly checking here? We are checking here the addresses in the memory of the nodes, because a node can have the same value, that is, a node can have values like 1 and 1, but it can never have same addresses in memory. So we check if the two addresses are same. If the two addresses are same, then that means that the pointers are pointing to the same node, and that's when we detect our loop. Here in C and C++, we check the addresses. In Python and Java, we compare the objects, if the objects are same or not. So here we check if the addresses are same, then we have found our loop and we return true, that there is a loop. And rest, we move fast pointer to 2 steps forward and slow pointer 1 step forward. And we keep doing this until we either find the loop or we don't have a loop, we reach the end of the linked list, we break the while loop and we return false. So that's it. Hope you understand it. We will put the solutions of both approaches, this fast pointer and using hash map, in our GitHub repository. So please check the link below. And I recommend you to code the naive solution of hash map yourself. Thank you.